Section 3.4, statements related to a conditional. Conditional statements are if-then statements. The example we're going to use throughout this lesson is, if it rains, then I need an umbrella. New statements can be formed by interchanging and negating the antecedent or consequent. Remember, the antecedent is the first part, the if part. The consequent is the then part. The converse of PQ is made by interchanging the antecedent and the consequent, so changing the order. PQ, our example was, if it rains, then I need an umbrella. The converse of PQ, switch the order, is, if I need an umbrella, then it is raining. The truth table for PQ and its converse. True and true, P implies Q is true. True and false, P implies Q is false. False and true, P implies Q is true. False and false, true. Converse is we're switching the order. True and true, true. False and true is true. True and false, false. False and false, true. The conditional and the converse do not always have the same truth values. The contrapositive of PQ is made by interchanging the antecedent and the consequent and negating them both. Using our example, P implies Q. If it rains, then I need an umbrella. The contrapositive of P implies Q is, if I do not need an umbrella, then it is not raining. We're going to look at the truth table for P implies Q and its contrapositive. First, P implies Q, true and true, true. True and false, false. False and true, true. False and false, true. The contrapositive is not Q, implies not P. I'm just going to go ahead and add a not P column here. False, false, true, true. And a not Q. It's going to be false, true, false, true. So now let's look. Our contrapositive, not Q, implies not P. False and false, true. True and false, false. False and true, true. True and true, true. Compare those columns, the conditional and its contrapositive. A statement and its contrapositive have the same truth values. The inverse of PQ is made by negating both the antecedent and the consequent. P implies Q. If it rains, then I need an umbrella. The inverse of P implies Q is, if it is not raining, then I do not need an umbrella. Again, looking at our truth tables, P implies Q, true, true, false, 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 true, true, false, false, true. I'm going to do our not P and not Q. False, false, true, true. Not Q, false, true, false, true. Not P implies not Q for the inverse, so false implies false. False and false is true. False and true, true. true and false, false, true and true, true. Looking back at our truth tables, the converse and inverse of a given conditional are equivalent. The converse and the inverse are equivalent. The biconditional statement is P if and only if Q. It is read as P if and only if Q. It is the conjunction of the two conditionals. P implies Q and Q implies P. P if and only if Q is true if P and Q have the same truth values. P if and only if Q is false if P and Q have different truth values. Biconditional rule. P if and only if Q is congruent to Q implies P and P implies Q. The truth values must be the same. Determine the truth value of each biconditional. 6 plus 8 equals 14. That's true. 11 plus 5 equals 16. True. Both sides of the statement are true. The biconditional is true. 6 equals 5 if and only if 12 does not equal 12. 6 equals 5 is false. 12 does not equal 12 is false. Both sides of the statement are false. So the biconditional is true. Both sides have the same truth value, so the biconditional is true. 5 plus 2 equals 10, if and only if 17 plus 19 equals 36. The left statement is false. 5 plus 2 does not equal 10. And the right statement is true. 17 plus 19 does equal 36. The left statement is false. The right statement is true. So the biconditional is false. We're going to construct the truth table for P implies Q, if and only if, not P or Q. P and Q, true and true. P and Q, true and false. P and Q, false and true. P and Q, false and false. Looking at our P implies Q, true, false, true, true. We're going to look at our not P column, false, false, true, true. Our Q column stays the same, true, false, true, false. Not P or Q. False or true is true. False or false is false. True or true, true. True or false, true. Looking at our two columns, P implies Q and not P or Q. Those columns are equivalent. So yes, the biconditional is true.